The motivation for this project is to demonstrate the principle of Newton's second law of motion, which gives the relationship between the net force, acceleration, and mass. The equation used to quantitatively visualize the application of Newton's second law is the following. A equals F net over m, where A is the acceleration, F net is the net force, and m is the mass of the object. Our goal is to determine if an object with greater mass will experience a smaller acceleration and net force than an object with a lighter mass, because acceleration and net force are inversely proportional to mass. We also seek to confirm the presence of unbalanced forces that causes objects to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. The physics concept used in this experiment was the principle of Newton's second law of motion, which gives the relationship between the net force, acceleration, and mass of an object. The slope of the velocity versus time graph will be used to find the acceleration, which is the rate of velocity divided by the change in time. Even more, the graph will reveal an initial segment with a constant positive acceleration, a middle segment with zero acceleration, and a final segment of constant negative acceleration. Furthermore, the force of each object will be compared using the following calculations. F of x equals mass times acceleration after calculating the acceleration. For our predictions, we believe that the heavier toy car has a lower acceleration and net force, while the lighter toy car has a higher acceleration and net force. Freefall will not be in effect due to an inclined plane being used. This project was produced by attaching two car tracks to a table and identifying the distance on the ground from the table to the end of the ramp, which was 72 centimeters, and the height of the track from the ground to the table, which was 74 centimeters, and the length of the track, which was 103 centimeters. Next, car 1 weighing in at 45 grams and car 2 weighing in at 34 grams were weighed on a mass scale. Then the cars were placed on separate tracks and held at the same distance. The cars were released at the same time, and the motion was captured on video for 3 trials. The velocity versus time graphs were produced for each trial using video analysis software to compare the acceleration of the two toy cars.
Trial 1, 3, 2, 1, go. Trial 2, 3, 2, 1, go. Trial 3, 3, 2, 1, go.
In this experiment, the acceleration of both cars in all 3 trials was 7.04 meters per second squared. The force from the incline of the black car was 0.32 newtons, and the force from incline of a yellow car was 0.24 newtons. In conclusion, this experiment revealed that objects with different masses will have the same acceleration but will experience different amount of force. This is because the force from the incline does not take into account the masses of the object, as it depends only on the angle and acceleration. Therefore, our original hypothesis is partially correct in that a greater force was needed for the heavier car and a lesser force was needed for the lighter car. However, both objects had the same acceleration because the masses did not affect the force of the incline.